All right, let's take a look at graphing linear inequalities. Now, when it comes to linear inequalities, there's two parts there, the linear part and the inequality part. Let's deal with the linear part first. Remember that when we're graphing a line, if we have it in slope-intercept form like this, y equals negative 1/2 x plus 3, we identified what the slope is, and that's going to be the number that is attached to the x, the coefficient there, and we identified what the y-intercept is, and that's what the b was, the 3. To graph it, we graph the y-intercept first. So since our y-intercept is at 3, we would put a point on the y-axis, 3 units up from the origin, and then we use the slope to find the next point. Remember that the slope had two parts to it. The numerator we said was the rise, and the denominator is the run. So to find our next point, we started at our y-intercept. We're going to rise -1, which means go down 1, and run 2. So we go to the right 2 units. That's where our next point is going to be. We can continue from there. Rise -1, run 2, all the way across our graph. And all of our points are going to line up in the same spot. So we grab our straight edge and draw the line. Put arrows at the end, and there we have a really good line. As for the inequality part, if we were to graph the inequalities that we've been dealing with, something like x is greater than 5, the first thing we had to do was find out where the 5 was. That was kind of our boundary, and then we decided whether it was going to be a circle or a dot, and that was based on whether or not x could equal that 5 or not. If x can equal the 5, we would use a dot, but in this case it's strictly greater than 5. It can't equal 5, so we would use a circle. Then we would decide which way our arrows got to point, because our arrow is going to cover all of our solutions. Right? And we want all of our solutions, all those x's, to be greater than 5. So they have to be larger than 5, and so we let our arrow cover everything that's larger than 5. Now when we put those two ideas together and come up with a linear inequality, something like y is less than or equal to -1/2 x plus 3, we have to do it in a way that we did that x is greater than 5 example, but make some adjustments for it being a line. So what I mean by that is when we graphed x is greater than 5, the very first thing we did was find the 5 because that's where our boundary was. Now that we're dealing with a linear inequality, we still have to find the boundary, but that boundary isn't going to be just one number or even one point. It's going to be that line, the line y equals -1/2 x plus 3. So we're going to graph that in the same way we just did. We identified the y-intercept as a positive 3, and we use our slope of down 1 over 2 to get our next point. Then we graph the line. So get our straight edge out and draw our line. After we found the boundary with that x is greater than 5, then we decided whether or not we use a circle or a dot, and that all depended on whether it was strictly greater than or less than, or whether it was equal to. When we're dealing with a linear inequality, we have to use that same idea. If we have or equal to, like we do in this example, then we would use a solid line. But what about when it's not equal to? How do we say we can go right up against the line but not touch the line? And that's going to be using a dotted line instead. The last thing we did when we were graphing the inequality was to determine which way the arrow had to point. And the arrow pointed to the side of the boundary that covered all of our solutions. And we have to do that same idea here, except we're not going to use the arrow. The only time we use arrows is at the end of our line. But we do have to identify which side of the boundary contains all of our solutions. So how we're going to have to do that is test points. So we start picking some points. I mean, we can pick any point we want. Maybe I want to pick 1, 1 and see if that works. So if we try 1, 1, remember with every point, the first coordinate is the x and the second coordinate is the y. So I'm going to take those values and substitute them into our inequality. So y is 1, less than or equal to negative 1/2 times x plus 3, where x is 1, and we try and simplify the right-hand side. So negative 1/2 times 1 is negative 1/2, and negative 1/2 plus 3, or 3 minus 1/2, is 2.5. So, is 1 less than 2.5? Yes. So that point is true. If we tried another one on the other side of the line, maybe we tried 4, 2. That would be right here. If we take those values, where x is 4 and y is 2, and plug that in, we'll have y is 2 is less than or equal to negative 1/2 x plus 3, where x is 4. So half of 4 is 2. Negative 1/2 of 4 would be negative 2. And negative 2 plus 3 is 1. So is 2 less than or equal to 1? No, it's not. And we can continue this with any other points that we want. And what we're going to find is that any time that we pick points that are above this line, all of these points are not going to be solutions. But anytime we pick points that are over on this side of our boundary, we're going to find all of these are yeses. So we have to show that on our graph, that which side of the boundary contains all of our solutions, and we do that by shading. So we just go ahead, take our pencil, and shade on this side of the line. So basically there's 3 parts to graphing a linear equality. The first one is graphing the line, so finding that boundary. The best way to do that, or the easiest way to do that, I wouldn't say best, is just using slope-intercept form. But then we have to determine whether it's going to be a solid line or a dotted line. And remember, just like circles and dots, the solid line is like the dot. So that's when we have the or equal to's. That's when we're going to use a solid line. Otherwise, if we just have less than or greater than, then we would use a dotted line. The last thing is to shade on one side. So how we know which side to shade is we test points. And we don't really have to test a lot of points. In fact, all we have to do is test 1 point. And I'll show you what I mean in the next example. Let's say we want to graph y is greater than 2x minus 1. When I look at y is equal to 2x minus 1, I can see my slope is 2, so as a fraction that's 2 over 1. And my y-intercept is negative 1. So we'll graph the y-intercept first at negative 1. And then we'll use our slope to go rise over run. We'll rise 2, run 1, and here's our next point. So we go ahead and get our straight edge out and line everything up, and we're ready to draw our line. Now be careful, before we draw our line, we have to determine whether we should be drawing a solid line or a dotted line. And since our inequality is strictly less or greater than, that's why we're going to have to use a dotted line. All right, we don't have that or equal to part. So this is what our line is going to look like. Next thing we have to do is shade. In order to shade, we test a point. And you can test any point that you want. You just want to make sure that it's not on the line. So we could pick something, doesn't matter. Maybe we pick this one over here. This is the point 3, 1. So I'm going to take 3, 1, where my x-coordinate is 3 and my y-coordinate is 1, and plug it into the inequality. So we have that y, 1, is greater than 2x minus 1, where x is 3. And we go ahead and simplify it. So I have 1 is greater than 6 minus 1, or 1 is greater than 5. Is that a true statement? Is 1 greater than 5? No, it's not. That means this point will not be a solution. And in fact, every point on this side of the line will not be a solution, which means all of my solutions have to be on the other side. So this is where all of my solutions will be. That means we have to shade on that side of the line. What about when we have a linear inequality that's not in slope-intercept form? Well, we do have a couple different ways to do it. One very good method is to take the linear inequality and write it in standard form, which means getting it to look like y equals mx plus b. To do that, I'm going to subtract x from both sides. So we'll have 5y is less than or equal to negative x plus 10, and then divide everything by 5. I'll get this 5 to cancel, so we'll have y is less than or equal to negative 1/5 x plus 10 divided by 5, which is 2. Now that it's in slope-intercept form, we can see that the y-intercept is 2, and our slope is negative 1/5. So we go down 1 and over 5. That's over to here. Now that we have our 2 points, we can go ahead and draw our line, grab our straight edge, like that. And we need to determine whether it's going to be a solid line or a dotted line. And since we're dealing with less than or equal to, the or equal to means solid line. So there's our boundary. Now we have to determine which side of the line we want to shade. So we test a point. Now I've just been testing any old point on the plane, but one thing that could be super helpful is why don't we just test the easiest point if we can. That's the point 0, 0. So if I'm going to look at the point 0, 0, that's when x is 0 and y is 0. When we plug those in, we have x plus 5y is less than or equal to 10, where x is 0 and y is 0. Well, 5 times 0 is 0, and 0 plus 0 would be 0. That's what makes 0, 0 such an easy number. But anyway, we look at that and we ask ourselves, is 0 less than 10? Well, yes, of course it is. So that means that point is a solution, and everything on this side of the line is going to be a solution. So this is the side that we have to shade. Now be careful when you're putting things into slope-intercept form. For instance, if we have 3x minus y is greater than 2 and we want to write it in slope-intercept form, what we would have to do first is subtract 3x from both sides to get all the x's, or to get the y alone, actually. And when we cancel out that 3x, we're not left with y, but we're left with negative y is greater than negative 3x plus 2. And we want it to say y is greater than, not just negative y, but y all by itself. To get rid of that negative, we would have to divide every single term by negative 1. Because negative y divided by negative 1 is y. But the thing is, we just divided by a negative number. And so our most important rule when dealing with inequalities, if you multiply or divide by a negative number, switch the inequality. Then we continue, negative 3x divided by negative 1 is 3x, and positive 2 divided by negative 1 is negative 1. So 3x minus 1. To graph that, the y-intercept is at negative 1, and our slope is 3, so up 3 over 1. There's our next point. Now we grab the straight edge, line it all up, and draw the line in. Should that line be a solid line or a dotted line? Well, since we're dealing with y being just less than, not less than or equal to, that means it's going to be a dotted line. So we graph like that. Last step, decide which side to shade on, and although it's close, this point 0, 0 is not on the line, so we can definitely use it. And I'm going to take 0, 0, plugging 0 in for x and 0 in for y, and go back to the original equation. So we have 3x minus y is greater than 2, where x is 0 and y is 0. Well, 3 times 0 is 0, and 0 minus 0 is 0, so I have 0 is greater than 2. Is that something that's true? Is 0 greater than 2? No, it's not. That means we would not shade on this side. Instead, we shade on the other side. So when it comes to graphing linear inequalities, you got to graph the line, determine whether it's a solid line or a dotted line, and then test a point to see which side of that line we shade on.